are you, my friends? In this video, I'm presenting an additional solved questions related to factoring for terms. And also, there are some questions in factoring that has rational exponents. I will be presenting around 10 different questions with complete answers. Just as a reminder, this is actually one of them here, one of the questions. To factor an expression, just take out the smallest exponent. See here we have 10. Look at the numbers first. 10 minus 5, 35. If there is a common in the numbers, take it. Now, if you look at the variable and the power here, or the exponent, look at the smallest, x power 7, x power 4, x power 3. So we take x power 3. Now, between 10 minus 5 and 35, I can take 5 out. So there are two ways you can write the one in the bracket here. 10 divided by 5 is 2. 5 divided by 5 is 1, and there is a minus. 35 divided by 5 is 7. That's one way. For the powers here, take x out. You can leave this power here. This is the power here, minus the power out. See this power here minus the power out. This power minus the power out. Now for the numbers, the second way is you can say, what do we multiply by 5 to get 10? So you write 2 here. 5 is out. You need 7 to be multiplied by 5 to get 35. So you can figure out any way which is easy on you. Now you simplify inside the bracket. 3 minus 3, that's a 0. X power 0 is 1. So that's all 1 times 2. 1 times 2. 4 minus 3 is power 1. So that's power 1, which is x. 7 minus 3 is 4. 7x to the power 4. Now, unfortunately, this one, we cannot factor it. But in the next example, you will see that we can factor it. So you have always to ask the question, can we factor more? I will say this again. You have to ask, can we factor more? If you can factor more, then you have to do it. Okay. Now, in the coming questions in this video, these powers, 3, 4, 7, these are integers. They can be rational, like fractions. 4 over 3, 7 over 2, even minus half, and all kind of powers or exponents. You will see now. Now here, look at this. We have 3m to the power 3 over 2 minus 9m to the power half plus 6m to the power minus half. See, we have different powers, all rational, positives and negatives, and we have also some numbers, 3, 9, and 6. You can pause the video if you like, please, and then try it. Use the previous example and see what can you factor here between 3, 9, and 6. For sure, you can factor 3. And then take what is the smallest power here? Smallest power is minus half. So take it out and see what will happen inside. Now, if you are ready, let's go and see the solution. All right. As we said before, let's factor out the smallest exponent. So 3 is there. 3 is the common factor between 3, 9, and 6. So remember, 3 is out, so there is no number here in the coefficient. Minus 3 is there, and plus 2. We know that. Now, m. Let's go to m here. Minus half is out because it's the smallest power. So I leave this power here, 3 over 2, minus the half. Because this is like m to the power 3 over 2 divided by m power minus half. We divide. Now, this one half, you see m half, that's in the given, minus the power out, minus the half. Minus half, minus the power outside, which is minus half. Now, sorry, here we have many minuses you have to deal with. Just take it easy and go slowly. 3m to the power minus half. Now inside here, 3 over 2 minus half. 3 minus 1, 4 over 2, which is 2. So this is simple now, m squared. Now here, half minus half, which is half plus half, 1. See, I write 1 here. And 1 means just m. Now minus half, minus half, which is minus half plus half, 0. M power 0 is 1. 1 times 2 is 2. This is what I was saying. Can we factor more here? Yes. That's a trinomial. 3 terms. If you know how to factor 3 terms, that's fine. If not, you need more information, you can go to Algebra course, lecture 11, factoring 3 terms. So this will be m minus 2, m minus 1. Remember, this is part of the answer here. So we can leave this answer here. You see this one here? This is the answer. Or I can make another form of the answer. Just another form. So I leave the 3, multiply the brackets m minus 2, m minus 1. And this is m to the power minus half, 1 over square root of m. You can leave it this way. You can leave it this way. Both are correct. Now, this is 4 terms. Well, maybe not easy question. Factor the expression completely. Maybe you can try here, please. X squared, y squared, minus 1, minus 2, xyz plus z squared. What do you think we can do? X squared, y squared. See, we have 4 terms. Usually in 4 terms, we can use grouping. See, factoring 4 terms will be lecture number 12 in Algebra course series in the playlist. So we can take here either 2 and 2, but it looks like it will not work. Or we can take 3 and 1. So we can see which 3 terms are related. I think x squared, y squared, xyz, and z squared, they are related somewhere. And then minus 1, we can leave it at the end here. You can try if you like, then I will show you the solution. Now, let's go. So here in these 4 terms, I explained that 2 and 2 by 2 will not work. So let's try 3 and 1. So if I take x squared, y squared, you see this one? Minus 2xyz plus z squared. If I take these 3 terms, then I leave the minus 1, you see? That will be perfect. Maybe a tricky question. Maybe you can say this is a tricky. See, this is like something squared, you see xy, minus 2xy times the z. You know the formula here, like a minus b squared, a squared minus 2ab plus b squared. That's the formula here. So we call this perfect. So these 3 terms will be perfect like this, xy minus z squared. And then the minus 1. Now this is a difference between 2 squares. See, this is like whole x squared minus y squared. So it will be xy minus z here, xy minus z. This is like a squared minus b squared. Remember the formula, a squared minus b squared. So it will be a plus b, a minus b. So plus 1 minus 1. If you multiply this, you get the question. Now let's look at question number 3. We have a little complicated question, but I'll try to explain it, please. Look on the left side, we have to factor all this until we get something on the right side similar to ax squared plus bx plus c, where a, b, c are numbers. After you do that, you add a plus b plus c. So the final answer will be a number. But the whole idea on the left side here is to factor this. And you know, since we have rational exponents here in the power positives and negatives, we can take the smallest power outside. So for sure in the denominator there is one term, just leave it. Here in the numerator, we just take out the smallest power. And remember the numbers 3, 5, and minus 2, there is no common factor. So let's start and see. See, we leave this one here in the denominator. Start with the left side. This is the left side. Factor out the smallest power. So the smallest power is 2 minus 3x to the power minus half. We have seen some questions in this video similar. So now what do I write? I write the 3 inside the big bracket. You see the big bracket? 2 minus 3x all to the power. The minus half minus the power outside. This is the way to do it. Or we divide, as I said, divide this by that. 2 minus 3x to the power half, you see this is power half, minus the power outside. Minus 2, 2 minus 3x to the power 3 over 2 minus the half. You have to go slowly here. Now, this one we can cancel. A minus half plus half, that's 0, power 0 here, which is 1 now. We will see that on the next slide. Half minus half, that's power 1 here, so I put power 1. Remember the 5, the coefficient. And here we have 3 over 2 minus half plus half. 4 over 2 is 2. See the squared here. 2 minus 3x squared. Remember now, on the left side, you have to expand it until you get similar to the right side. Let's continue, please. You can pause the video if you like here and simplify everything on the left. See, before the equal. Try to simplify this and see what is A, what is B, what is C after simplification. So from the previous slide, we can see this expression is equal to ax squared plus bx plus c. I see the first power here, power 0, that's 1. So this is so easy. Power 1 means nothing in the power. So 2 minus 3x. Now power 2 here, we have to do something. 2 minus 3x. 2 is like u here. See, this is the formula. I'm just reminding you of the formula. This is 2 like u. This is minus. This 3x all like v. See, the formula says u squared, I think you remember that, minus 2uv plus v squared. You can put here x and y, you can put a, b, anything. So this is 2, see the u here, squared, that's 4 here. Minus 2 uv, which is minus 2 times 3x, so minus 12. Plus v squared, see the v itself here, 3x squared, 9x squared. Now remember here, you have to expand this. So 3 is there, 5 times 2 is 10, 15x minus 8 plus 24 minus 18x squared. Now you combine here everything, like terms, combine the like terms, you get minus 18x squared, minus 15 plus 24x is 9x, 3 plus 10 minus 8 is 5. So now we can see A is minus 18, B is 9, C is 5. Add them, you get minus 4. Nice question. I know it's not easy. Okay, now let's see question number 4. We have 2 parts, 4 terms. We need to factor the expressions completely. Let's take one by one. P squared q squared minus 10 minus 2q squared plus 5p squared. Maybe this one is easier than the second one. Okay, let's start. Now, once we see 4 terms, we have to think of grouping 2 and 2, 3 and 1. It depends on the question, actually. There is no rule here. So let's see here. We can use grouping. So I can take the first 1 and 4, the first and the fourth one. second and third. See, just you can rearrange here all the terms the way you like. So I put p squared q squared and then 5p squared there. And then I can leave minus 10 there, minus 2q squared. You can just move the terms any way you like. You have to keep the signs. Okay. Now, what's common factor here? P squared. You can see p squared. Inside, we have q squared plus 5. Also here, I can see minus 2 there, minus 2 there. So I take minus 2 out, and then there is a bracket, q squared plus 5. See, now this is common here. So nice. So q squared plus 5 is common again. Out. This is grouping, actually. P squared minus 2. Now, we remember this difference between two squares, x squared minus, should have minus here, y squared, x minus y, x plus y, or x plus y, x minus y, same. This one, because we have a plus, we cannot factor it in real numbers. See, this is the formula here, no factoring for x squared plus y squared in real numbers. This one I can factor. Since number 2 is not perfect squared, so it will be p plus square root of 2, p minus square root of 2. You can also write the minus here, the plus there. It's the same. So that's the factoring for this nice question. I advise you, take a minute, please. Pause the video, try this one. We have cube, we have squared, we have power 1, x and y. It's only x and y. Try it, and if you are ready, let's go to the solution of part 2 in question number 4. Let's see. Now, also we have to use grouping. I will take, look out here, was x squared y, I can take with x cubed. See, because we have a power here, this is only one y. Y squared y cube, I can take together here. So I can take the first and the third, second and fourth. Now, what's common here? X squared is common, so y plus x, you see? Y here plus x, because x squared is out. Now, what is common here? Minus y squared. Minus, you see, minus y squared. So x is inside plus y. Now, is this the same, y plus x, x plus y? Yes. Y plus x is exactly x plus y. But if we have a minus, it's not the same. So we take it out, you see? X plus y or y plus x, we can take it out. You can write it at the beginning. You can leave it here. Then x squared minus y squared. You can take x plus y at the beginning. It's the same. Now you can use also this formula, nice difference between two squares, which is x minus y, x plus y. Now we notice that we have this factor here, x plus y, the same number, same factor here. So we can just write squared on it. Like m times m is m squared, w times w is w squared, x plus y is x plus y squared. That's the final answer for this nice question. Now let's see another. Factor the expressions completely. We have here 4 terms, and here we have 3 terms. Okay, 4 terms here, a power 7, b. What do you think we can do here? You can take any 2 terms together. You can just rearrange it. Use grouping. Remember, in any question in factoring, if there is a common factor in all terms, remember all terms, you have to take it out. So here we have a and b, a and b, a and b, only power 1. So take it out. Now, if you take ab from here, only you left with a power 6. If you take ab, only a cubed is there. If you take ab, it's b cubed, a cubed. If you take AB, this is B cubed. Now inside is 4 terms, we can use grouping. But remember, before we continue here, AB, you see this AB? It should be part of the answer, don't forget it. See, AB is out, AB is out, AB is out, AB is out, AB is out. Always it will be outside, but in the answer, in the final factor. You see, this is like 2 meters, the answer here. Okay, let's take the terms 1 and 2, 3 and 4. See, 1 and 2, what is common here in 1 and 2? A power 6, A power 3, what is common? A cubed. See, easy, A cubed. So A power 6 divided by A cubed is A cubed. And this is, if you take it out, you are left with 1. Now, what is common here? A cubed, B cubed, minus B cubed. I take the minus out from both. Also, I take B cubed. So what's left inside? A cubed plus 1. See, this is the same inside the bracket. This is grouping. This is a common factor. So I take it a common factor. This one, same common factor. Now I have A cubed minus B cubed. See, I have a cube. Then I put here for you, just to help you here, I put 2 formulas for the cube. One for the sum of 2 cubes. This is the factoring. And this is the difference between 2 cubes. That's the factoring. Use the first one for this, A cubed plus 1. You get this and this. Use difference, second formula for A cubed minus B cubed. It's so easy. I can help you more. You see A cubed plus 1, go here. So X will be A and Y will be 1 because 1 is the same as 1 cubed. Clear now. Now when you take A cubed minus B cubed, according to this formula, X will be only the A and Y will be the B. And just write the formula here. Remember, there is no 2 here in the formula. There is no 2 in the cube formula. That's the first part. So nice question. First part. You want to try the second one? Second one is 3 terms. Just to remind you how to do 3 terms. Now, 3 terms, you have to play with this. You see, there is t squared minus 4, 4 minus t squared. These are not the same, you see? So you must know that 4 minus t squared, if I take a minus out, it will be t squared minus 4. See, just try it. Multiply minus times t squared will be minus. Minus times minus 4 will be plus 4. So instead of this bracket here, you see this bracket, I can write all this with the minus, you see? So the minus now, it will be with the 17. See this minus. Now I have the same expression inside the bracket, t squared minus 4. To make the question simple and easy, I can say let capital M is equal t squared minus 4. So now I have what? Capital M here squared minus 17 capital M plus 60. Okay, so this is a leading coefficient here 1. If you need to know how to factor these, we call these trinomials. See, trinomials, because we have 3 terms. You can see the video on factoring 3 terms. It will be about trinomials. There are many, many examples, simple, medium, and difficult. So because we have the leading coefficient here 1, you see, that's easy. Now suppose you have here 5 or 6 or 2 or 3, not 1. You need more difficult methods. You can find them in this video factoring 3 terms. Okay. Let's see, the leading coefficient is 1. So the number in the middle here is the sum minus 17, and this number 60 is the product. Try to find from your mind, find 2 numbers, exact numbers, their sum is minus 17 and their product is 60. For sure the numbers should be negative, minus and minus, because when you add them you get, you see, minus 12 minus 5, if you add you get minus 17. If you multiply them you get positive 60. So it will be m minus 3, m minus 5. That's the factoring for this, remember? This is the factoring for this. We cannot leave it here. This is not the final answer. Why? Look at the question. The question is in t. We cannot leave the answer in m. Okay, let's continue now on the next slide. So I have the factoring here, m minus 12, m minus 5. So remember, capital M here, we see let capital M, here one, is equal to t squared minus 4. Remember that. It's written here, capital M. So in this capital M, I put t squared minus 4. In this capital M, I put t squared minus 4. Now, minus 4 minus 12 will be minus 16, and this is minus 9. I can factor this by difference of two squares. So this will be t minus 4, t plus 4. And then also I can factor this t minus 3, t plus 3. Very nice factoring here. T minus 4, t plus 4, t minus 3, t plus 3. Now, this is question number 6, where we have rational here in the exponent, rational numbers, positive and negatives. We did the first two examples. Let's try these two, please. See, the idea is known. Take the smallest power outside. And here also take the smallest power outside. Let's see the first one. First one is simpler, I think. See, the exponents are 1 over 4, minus 3 over 4, minus 7 over 4. So the smallest power is this one, minus 7 over 4. Now, you know the story. I leave this one, x power 1 over 4, minus the power outside, because I divide this by this. So when I divide, I subtract the power. Minus 3 over 4 minus the power outside. Minus 7 over 4 minus the power outside. Now I have to simplify, play with the fractions here. 1 minus minus 7, so this is 1 plus 7 over 4. What is 1 plus 7? 8 over 4 is 2, so this is 2, which means squared. Now, minus 3 minus minus 7 plus 7, so that's 4 over 4, which is 1 here. Now, minus 7 plus 7, that's 0 over 4 is 0. Now, x power 0 is 1 multiplied by 2. X power 1 is the same as x. X squared is x squared. Now, remember I told you, if you can factor this, you have to factor it. And this is a trinomial, actually. So easy to factor. X minus 1, x plus 2. And this is x power minus 7 over 4 is part of the answer. You see, this is part of the answer. Now, you can try, please. You can try the second one here. It's a little more difficult. Look at the power, half, power minus half, power minus 3 over 2. Take the smallest power and see what will happen inside the bracket. If you are ready, we can go. Yes, let's see. Factor out the smallest. Now, the smallest is x minus 1 to the power minus 3 over 2. We will do the same method. X minus 1 to the power half minus the power outside. X minus 1 power minus half minus the power outside. Minus here, see we have a minus. X minus 1 to the power minus 3 over 2 minus the power outside. Now it's easy, inside the bracket you have to work with the powers. 1 plus 3, which is 4 over 2, we have seen before, squared. This is minus 1 plus 3, 2 over 2 is 1, and this is 0. Remember, x minus 1 to anything power 0 is 1, so that's 1 here. See the last one here. See this one here is the last one. Now we have here x power 1, which is only x minus 1. So the x minus 1 in the bracket, this is x minus 1 here. And the squared I put here, you expand it. X minus 1 squared will be x squared minus 2x plus 1. Remember the formula here. So this is the formula. Now when you simplify everything, you get x squared minus 2x plus x is only minus x, plus 1 minus 1 cancelled. I have only 1 minus 1. I cannot factor this. See, I just leave it. This is the answer here. This is the factoring for this whole big guy. Okay, thank you for watching this video. If you like it, you can subscribe, share it to your friends, and then I wish I can see you in another video with another topic. Thank you very much.